Today, learning target 2.2, understand the concept of a function and use function notation. Don't worry about that F1, that's for my own benefit. Okay? First vocab word is a relation. Okay? I'm not going to quiz you on vocab, but I want to just go over it with you. A relation is simply a mapping or a pairing of input or domain values with the output or range values. Okay? It's a pairing of input values with output values. It's a pairing of x values with y values. It's a pairing of domain values with range values. Okay? I hope you understand that those terms that I'm using. All right? A relation is simply a pairing of input values with output values, or x values with y values. Okay? There are four ways you can represent a relation. You could just write a bunch of ordered pairs. 2, -1, -2, 5. Okay? 3, 4. That's a relation. Why is it a relation? Because it's a pairing of input values with output values, domain values with range values, x values with y values. That's a relation. It's a set of ordered pairs. Okay? It could also be represented on a graph. On a graph, all it is going to be is a bunch of coordinates plotted. So -2, 5, 2, -1, 3, 4. That's also a relation. It's got some x values paired with y values. Here's an x value paired with the y value. There's an x value paired with the y value. There's an x value paired with the y value, or domain value paired with the range value. Okay? Table, what do I mean by table?
X, Y.
An XY chart. Yep, a T chart. Okay, whatever you want to call it. XY chart. And then you got 2, -1, -2, 5, 3, 4. Okay? That's a table of values. It's another way to represent a relation. And then you got a mapping diagram. This one you're not as familiar with, but here's what it looks like. Usually got a domain box, you got a range box, you put the numbers in some order. I'm not too picky about the order. Okay? Obviously I'm very numerical in my order. 2 is paired with -1, so what we do is we draw a mapping diagram showing how which x value is paired with which y value. -2 is mapped to a 5, and 3 is mapped to a 4. That's a mapping diagram. You're mapping the x value with its corresponding y value. That's an example of a mapping diagram. Okay? So you got a set of ordered pairs, you got a graph, you got a table of values, you got a mapping diagram. All four of those things are ways you can represent a relationship of x values with y values. And you've seen them all. You've seen this. We didn't do a lot with it, but you've seen it. Questions? Okay? You may need more time with that. Thank you, sir. All right. I'm going to slide up, so I'm going to erase for right now. Next keyword is a function. A function is a relation in which each value in the domain is paired with exactly one value in the range. Or in other words, every x value has only one y value that goes with it. Every x value has only one y value that goes with it. This XY table here is an example of something that would be considered a function, because every x value has only one y value that goes with it. 2 is paired with -4. Is 2 ever paired with anything else besides -4? Nope. So So therefore it's okay, it's a function. Okay? 3 is paired with -1. 8 is paired with 9. That would be a function. Alright? Even if I change them all to -4, is it still a function? Yeah, because every x value is paired with just one y value. Okay? That is fine. But now if I would do this, this is still a function, but now this is not. Because the first time you plugged in a 3, out came a 2. When you plugged in 3 for x, out came 2 for y. The next time you plugged in 3, out came a 7. Not a function anymore. Because one x value has more than one y value that is paired with it. So this would not be a function.
Is that even possible?
Okay? Not on a function, but could a graph have, like could you graph something where one x value has multiple y values? Absolutely. Okay? Want to see an example?
Yes, sir.
Okay? X equals y squared plus 1. Okay? Would you agree that, oh, I don't know, would this be a solution to that equation? You plug in a 5 for x and a 2 for y, does it satisfy?
Yeah.
Is that also a solution to this equation?
Yes.
Yep.
So one time you plug in a 5 and out comes a 2, next time you plug in a 5, out comes a -2. Therefore this is not a function.
Okay.
What does this look like graphically? A sideways parabola. Okay? This would look something like this. Something like that. Okay? So this is an example of something that is not a function.
Will we do those?
Okay? You're not going to be graphing these now. No. But I'm just, you wanted an example, so I gave you an example of when that could happen. Okay? So, we talked about whether something is a function or not. You can also do a vertical line test to see whether something is a function or not. Okay? If a vertical line passes through a relation in more than one point, it is not a function. It is not a function. This graph demonstrates that. A vertical line, does it hit the graph twice? Yep, so therefore, not a function. Because one x value has 2 different y values that goes with it. Not a function. Okay? You can do a vertical line test. Doesn't always have to be with a graph either. Sometimes, or excuse me, with an actual continuous graph. Could just be a bunch of dots. A bunch of coordinates. Is this a function right now?
Yes.
Yep, because every x value that you see up there has only one y value that goes with it. Is this a function now?
No.
No, because here's an x value that has 2 y values that goes with it. It does not pass the vertical line test, so therefore it is not a function. Any questions on that? Pause so I stay under 15. Hopefully I'm under 15.
And you're at 8:40.